Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on these sine and cosine graphs. From what I understand, this is the only thing that you got to learn how to graph is sine and cosine. And you probably learned the method of box graphing at this point. So I'm going to show you how to graph all these and find all the stuff that you need to graph out. Let's see here. Are any like weird ones on here? Graph each, graph them, graph it, graph it. Do you have to like talk about the amplitude and period and all that stuff? I wonder. Well, whatever. We'll just like graph whatever we need to with these. Let's do 10/7 the odds, and yeah, we will just use the uh, hmm. Yeah, we'll just use the box method the whole way through. Okay, so I hope you don't mind, but I'm going to be like shifting over to like these, the smartboard stuff to graph these. So it might be a little confusing. I apologize for that, but I want some space, right? And I don't really use these graphs too much to like get a sketch of the period too often. So anyways, so the first thing we're going to graph out is the cosine of theta, okay? And I'll try and like tell you about like the different parts of it as well, okay? So y equals the cosine of theta. Ooh, and let's maybe make that marker a little bit. There we go, thinner, yeah. Okay, yeah, that's better. Y equals cosine of theta. Okay, so here's what I know about cosine and sine, all right? The total length of a cosine or a sine graph, like it's called its period. And the period happens when like it goes through one full rotation of its pattern. So cosine looks like this generally, okay? So it's like it starts up at like an apex, and that has to do with like the unit circle, like at 0 degrees, it's at its biggest value of cosine, which is 1. And then at 90 degrees, it goes to its lowest or second lowest value, which is 0. And then its lowest value is -1. And I'm talking about like integer value, lowest value, and stuff like that. It's because cosine represents the x-axis on a unit circle. And, when it's back in the middle, it goes back to 0. So it's like it constantly goes like this: 1 and then 0, and then -1, and then 0, and then 1 again. And it keeps going in this pattern, right? So if and I'm talking about cosine in this case. So at 0 degrees, right? Like so, imagine that this is like the x-axis is the degree axis, and then the y-axis is still the y-axis, like how high up it goes. If it starts at 0 degrees, so like right on the y-axis, the first value that you get to at 0 degrees is 1. So the height is 1. It goes to this coordinate right here. And then after like 90 degrees, okay, so after 90 degrees, then it's like over here, it's at 0. Okay, so it goes like down to here. And then at 180 degrees, so, double that length. So from 0 to 90, 90 to 180, it's now at its lowest point, -1. And then at, then now it goes to 270 degrees as it's rotating around, and it goes back to 0. So at 270 degrees, it's back at 0. So we'll say that's like 270 right there. And then when it goes back to its full, 360 rotation, it goes back up to 1. So let's say that's 360 degrees. It basically goes in this pattern, and it keeps repeating itself over and over again. It's like 1 and then 0, and then it goes down to -1, and then back up to 0, and then back up to 1, and then it'll go down to 0, and then to -1, and then to 0 again, and then to 1, and then back to 0, and then to -1, and then back up to 0, and then to 1, and so on. It just has this like repeating pattern over and over again. So the period is like, one of those patterns. So like if I were to take this graph right here, this is what we call like the period of the cosine graph. Like, and we just like stop it, start at 0 and go all the way up to 360 degrees. I could take that pattern. In fact, I will. I'll take that pattern and I can move it. Oh man, I have a little pointer thing. There we go. And I can move it and get the same pattern like over here and over here. You see, like it's the same pattern over and over again. That's the period, okay? And we can find that period length just by memory. The period length for along the x-axis to like get one of those patterns for a sine or for a cosine is 360 degrees. So the period, just like for a regular old sine or cosine, if we're talking about degree measurements, is always 360 degrees. Okay, it starts off that way every single time. And the only way that you can actually change the period is by multiplying that theta by some number, okay, in either one of those cases. If we're talking about radians, one full rotation, one full period for a sine or a cosine is going to be 2 pi radians, okay? So it could be either of those depending on if we're talking about, degrees or radian values. Another interesting feature about like the sine and the cosine graphs is this. If you multiply by some number in front of the sine or the cosine, let's just arbitrarily pick sine for the angle measurement, or for the number that for the thing that we're multiplying with, for the thing that we're using the starter graph. This a value is called the amplitude, and what it does is it goes something like this. Sine is this pattern, right? But if I multiply by some number, like maybe 10 in front of it or something like that, okay, so we change that to a 10 now, then what'll happen is that the sine pattern, it jumps up. We call this thing the amplitude, and the amplitude gets increased with whatever multiplying factor that we have in front of the sine or the cosine. So I know you probably you just want the procedural stuff. So I'm going to get to that in a second. I just got to talk about one more thing, and that's changes to the period, which is called like a shortening or lengthening of the period, and also these things called phase shifts, which move the graph to the left or to the right. So those all happen like on the theta. So if you have some function of your theta, okay, and if you have some number that's multiplying on the theta, like some number, whatever it is, multiplying on theta, what happens is that b value affects the length of the period, okay? So typically what we're going to be able to do to find the length of the period is just take whatever is multiplying on theta and divide that by either 360 or, if we're talking about radians, into 2 pi. And that should give us the period length that we need for our function, okay? And then if we add some number or subtract some number onto the theta value, this thing is called like a phase shift, okay? So we'll see what happens with that. So phase shifts are what happens when you move the graph to the left or to the right, and they're pretty easy to spot, okay? All right, so what we're going to do for every single graph that we have, it doesn't matter what it is, we're going to answer a bunch of questions, okay? We're going to answer the following. We're going to talk about the amplitude, okay? So we're going to find the amplitude for every one of the graphs that we're going to make. We're also going to talk about the period, and we're also going to talk about the phase shift, if there is a phase shift at all, okay? So phase shift. And there's one additional thing that you could do, and that's taking like, a cosine or a sine or whatever and adding some number onto it, okay? So that's what we call a vertical shift. So we'll see if there are any vertical shifts as well. All right, so this is what we're going to do for every single one of our graphs, all right? Amplitude, period, phase shift, and vertical shift. All right, so let's get started. Let's start with a really easy one, cosine. And we'll graph it up using box method. So here we go. Ready? So y equals, I don't know why the pen keeps doing that, darn it. Okay, so y equals cosine of theta. All right, so here's the first thing, amplitude. If all you got to do is look and see what number is multiplying on your sine or your cosine. What number is multiplying in front of cosine? Can you tell? It's just number 1, right? So I could put a 1 out front, and it doesn't affect anything. It doesn't change my cosine. So that'd be a 1. My amplitude would be 1. If I had like a 2 in front of the cosine, I'd put 2. If I had a 3 or whatever in front of the cosine or in front of the sine, I would put that as an amplitude. I'm trying to think, what other things are there? There's also reflections. Oh yeah, vertical reflections. So reflections sometimes show up, and we'll talk about like what that looks like when we see it. Okay. All right. So amplitude is 1. Next up, we talk about the period. So here's what I do for the period every single time. Okay. I put whatever I've got in the parentheses, I put that in the middle, and then I just see how far apart, theta is from my two values. So if we're talking about degrees, I put 0 to 360, and if there's nothing multiplying on my cosine, that stays the same, or my theta, that stays the same. But what I would do is I would take that equation, put it in this inequality right over here, and then what I would do is I would just solve for theta. Okay, solve for theta. And that tells me two things. It tells me my phase shift and also my period every single time. I'm not even kidding. Every single time. Okay. So the period in this case, since theta is already solved, there's no shift in the phase, and there's no difference in the period. So the period is still going to be 360 degrees. The phase shift, there is none. And the reason why there's none is because this thing stays at zero. So that's what I look for when I look for my phase shift. Okay, maybe I'll color code some of this stuff. Green, that's going to be my phase shift right there. Okay, that tells me the phase shift. And if I have any numbers out front of my in front of my theta, that's going to tell me the period. Okay, so it'll like be a number that's in front there. And the amplitude is always going to be the number that's in front of my sine or my cosine. What other ones are there? Oh, okay. There's also vertical shift and reflection. Vertical shift, we'll talk about that. That's actually part of the amplitude. So maybe I'll put purple under that one for, sorry. That's for reflection. So if I see a reflection, that's going to be reflected with the amplitude. And vertical shift is going to be if there's any numbers that are like adding or subtracting at the end over here. Okay. All right. Yeah, that's a pretty good idea. Let's start there. Okay. So this is how I always set up these problems. Okay. So keep going. So vertical shift, there is no number over here that's like adding or subtracting. So there's no vertical shift. And then a reflection. Well, the secret is if the amplitude has a negative in front of it, it'll be a reflection, but there isn't a negative on the amplitude. It's just a positive one. So there's none for that one. So this is a really boring problem. All right, so now we do our little box method, and here's how it goes. I don't know where that yellow came from. All right, so let's see. 3 lines here and 3 lines in the middle. There we go. Okay, so a cosine graph always looks like this. It starts up at the top, and then it goes to the middle, and then down, and then up, and there. So there we go. And then we just connect the dots. This is how every cosine graph is going to look unless it has a vertical shift. So every single cosine graph that you have will look like this. Every one of them, okay? Every single sine that you have is going to look like this. So let's do the exact same thing, but we'll do sines on this page, okay? And here's the deal. I'm going to try and keep this very, very consistent. So amplitude, and the next thing that I have is the period, and then the phase shift, and then the vertical shift, and then a vertical reflection. That's what I wrote, right? Vertical reflection. Oh, no, just reflection. Okay. Purple for amplitude and purple for reflection, yellow for vertical shift, and then green for the phase shift, and red for the period. Okay. And then this is for the sine stuff. So y equals, come on, sine of theta. Ugh. It's getting really annoying. Stop it. Theta, and all the colors that were up here. So we had amplitude in purple, and then the period in red, and then phase shift was, so we had 0 less than or equal to theta less than or equal to 360, and then that was like the green part right over there. Okay, and then yellow was the vertical shift. Okay. Here we go. Yeah, this is gonna work real well. All right, so let's see. And also the sine graph. The sine graph is always gonna look like this. I'm gonna change it up. Maybe come on. I'll change up the sine graph only if there's a reflection, okay? But every other time it's gonna look exactly the same. It'll look exactly like this. Sine starts in the middle, goes up, and then back to the middle, and then down, and then back to the middle. So every single sine graph that you're going to graph until it gets a reflection is going to look like that. Okay. All right. So here we go. Ready? Boy, this is going to be fun. All right. So our first graph is cosine. We're just about done with this. It's always centered at 0 unless there's a vertical shift. So put 0 in the middle on the y-axis. And then the amplitude goes up by 1 each time. So we're going to go up on the y-axis and down on the y-axis by 1. And then here's the interesting thing. So our x-axis is going to get broken up into quarters, okay? So we start at the beginning of our period, which is 0, then go to the end of the period, which is 360, and then we go in the middle of it. So halfway between the 0 and 360 is 180. And you can find the halfway between them by doing the mid value. So 0 plus 360 divided by 2, and that's how you get 360. That's equal to 180. Sorry, that's how you get 180. You just use your calculator. And you can do the same thing here, 180 and 360. If you want to find the halfway point between those two, like between this one and this one, to get this value. 180 plus 360 divided by 2 gives you 270. So 270 would go right there. And then halfway between the 0 and 180 is 90. So that's all you need, actually. You're done with your graph of the cosine function, just like that. All right, now check this out. Here's how this is going to work. I'm going to go through like a bunch of these really, really quickly to show you how fast this is using radians or, angle values in terms of degrees, sines, cosines, whatever. So let's do number 5, okay? Number 5. So y equals 4 sine. So I just think to myself, okay, well, this is sine, so sine is going to go here. And then I've got 4 times the sine. All right, so here we go. Ready? The amplitude. So the amplitude's that purple part right there that's in front of the sine. So the amplitude is 4. It's not negative, so there won't be a reflection. So I can say none for that one. There's no vertical shift because there's no number like over in this area right over here. So there's nothing there. All right. There's not going to be any period change because there's nothing multiplying on the theta at all. So there's no, the period's still the same. It's 360 degrees. Or did they ask us to do radians for this one or what? Okay, so it looks like the axis is in terms of degrees, so it is degrees, so that's fine. Okay, and then the phase shift. Since this stayed at 0 when we solve for theta, it's still going to be like at the same spot. It's going to start. There's not going to be any movement to the left or to the right. So this is how our sine graph looks. We only need to change a couple things. Since there's no vertical shift, it starts in the middle, 0. The amplitude is 4, so we're going to go up by 4 each time and down by 4 each time. And then the x-axis is going to start at 0, and then it's going to go up to 360. And then I just keep going in the middle. So 180, and then halfway between 180 and 360 is 270. Halfway between 0 and 180 is 90. There's our graph for sine, for sine of theta. Okay. All right, now let's take a look at another one. So it looks like we've got 2 cosine minus 2. All right, so yeah, let's do that one. We've got to go to the cosine graphs now. And this is going to be 2 cosine of theta minus 2. Okay, here we go. Ready? So let's start writing this stuff up. We're going to have to change that up maybe. All right, let's see what we've got. So this is the cosine graph. It's always going to look like that. Let's start answering some questions. The amplitude. So it looks like the amplitude is 2. There's no negative on that 2 over there. So that means that we're not going to have a reflection on it. So none for the reflection. Okay, the vertical shift. We do have vertical shift. So it's going to be a -2 now. Okay. And then phase shift. Well, there's no period change. So it's going to be 360 degrees or 2 pi. Let's see what the graph is. Is it in terms of degrees? Yeah. Okay. So it is 360. And then the phase shift. Well, since theta is all by itself, I didn't have to solve for theta, so it's still going to be there's no phase shift because it's still at 0 over there. So here's how it goes. We're going to go from 0 to 360 again on the x-axis. Halfway between is 180. Halfway between 180 and 360 is 270. Halfway between 0 and 180 is 90. Now here's what's interesting. The vertical shift means that everything has been shifted down by 2. So you know how we usually start at 0 here? We're going to drop that down by 2. So now it's going to start at -2. And then the amplitude is going to be 2. So from the center line, we go up by 2 each time. So go up by 2, you get to 0. Up by another 2, you get to 2. And then we'll go down by 2 each time. So go down by 2 to -4, down by 2 again to -6. And there's your cosine graph. Literally, that's all that you have to do for it. Okay, we're going to keep going. So check it out. This is the box method. It's not that bad. Graph each function. Now we're using radians. So now we've got 2 sine of theta. So let's go to the sine graph. Sine graph's right here. So now it's going to be 2 sine of theta. So So here's what we need to change. Instead of going from 0 to 360, now it's going to be from 0 to 2 pi. All right, and let's see what else gets changed. All right, let's see here. Okay, so here's our sine graph. That stays the same. It does not change at all. It looks like there's a 2 for the amplitude, so our amplitude is 2. It's not a negative number, so there's no reflection. We don't need vertical shift because there's nothing like written out over here anywhere. So none for that. And that's good because that means it just starts at 0. There's nothing multiplying on the theta, so there's no change in the period. It's still going to be 2 pi. And the phase shift, well, there's nothing that's multiplying or adding on to the theta inside the parentheses, so it's not going to affect the phase at all either. So there's none for that either. So we start at 0, we go to 2 pi, and then halfway between 0 and 2 pi, so halfway between 0 pi and 2 pi is 1 pi, and halfway between 1 pi and 2 pi is 1.5 pi. Halfway between 0 and 1 pi is 0.5 pi, or pi halves. All right, and then the amplitude is 2, so from 0 we go up by 2, and we go down by 2, and just like that, we've graphed this thing out in radians. All right, let's go to the next one. So the next one after that, number 11, is -1 plus 2 cosine theta. Well, first I rewrite that, because if I have some value that's in front, I just move it afterwards, so it's going to be -1. So that's how I'd really write up the equation, 2 cosine theta minus 1. And then it's cosine, so I go to the cosine graph, and I write it up. So now it's 2 cosine minus 1, and let's see how that affects things. Well, first off, it's radians, so it's going to be between 0 and 2 pi. So this stuff's going to change up a little bit. And then let's see what else changes. All right, here we go. So the amplitude is 2 because that's what's multiplying in front of the cosine. It's not negative, so there's no reflection. I should put an N there for reflection, not reflectio. We do have a vertical shift. We have a -1 there. There's no phase shift because it's not moving to the left or the right. There's nothing adding or subtracting onto the theta, so none for that. We'll see that in a little bit probably. And then the period, there's no number that's multiplying on the theta, so the period's still just going to be 2 pi. So since it's 2 pi, we start at 0, we go up to 2 pi, and then we just go halfway between. So halfway between 0 pi and 2 pi is 1 pi, and halfway between 1 pi and 2 pi is 1.5 pi, and halfway between 0 and pi is 0.5 pi. All right, the vertical shift means that instead of writing 0 here, it's going to be a -1. And then the amplitude says that we're going up by 2 each time. So from -1, if I go up by 2, that puts me at 1. If I go up by 2 again, that puts me at 3. If I start at -1 and I go down by 2, I get to -3 and then -5. And that's the graph right there. Because cosine's always going to stay the same. It looks like the same pattern. Same thing with sine. Okay, there you go. There's another graph for you. Let's take a look at number 13. Graph each function using degrees. So now we finally do have something that's affecting the theta. So this is going to affect the period on the graph. All right, so let me show you how that affects it. So it's going to be a sine graph, and it's sine of 3 theta. So here we go. Let's go to the sine graph. Now it's going to be sine of 3 theta up there. Oops. Sine of 3 theta. All right, here we go. So once we have like something in the parentheses, we change that theta there to 3 theta. And it was in degrees, so that's 0 to 360 for our period. All right, and let's see how that affects everything. Okay. So the amplitude, there's no number multiplying out front, so we put a 1 there. 1's positive, so there's no reflection. If there was a negative, we'd have a reflection, but that's not the case. There's no number that's adding or subtracting outside the parentheses, so there's no vertical shift. There's no number that's adding or subtracting inside the parentheses either, so there's no phase shift. The only thing that's going to be a little bit different is the period. So here's how we can figure out the period. It's really, really easy. You can take 360 and you can divide it by whatever number is multiplying on the theta. So divide by 3, and it'd be 120. Okay, so 120 is the period, 120 degrees instead of 360 degrees. And let me show you why that works. Okay, usually theta is supposed to be between 0 and 360, but if I solve for theta in this case, in this inequality here, that I've made, I'd have to divide everything by 3. So if I divided 0 by 3, I'd still have 0. So that wouldn't really change. But then if I divide the 360 by 3, oops, I don't know why I did that. If I divide the 360 by 3, this turns into 120 degrees. So if I divide every single thing by 3, I get that theta has to be between 0 and 120. In other words, that's the limitations on the x value. So we start at 0, we go to 120, and we do the same thing that we did before. We just find the halfway point. What's halfway between 0 and 120? That'd be 60. What's halfway between 0 and 60? That's 30. What's halfway between 60 and 120? And that'd be 90. If you might have picked up on this, that whatever this length is going to be the same length from each number to each number. So if it's easy for you to think of how far away the spaces are, that might be simpler for you too. So this is no vertical shift. This starts at 0. Since the amplitude is 1, we go up by 1 and down by 1. And there's the graph of our sine function with a brand new period instead of 0 to 360. Okay, let's see what the next one looks like. So that's number 13. 15. So we've got 2 cosine 2 theta. So that 2 theta should have a parentheses wrapped around it. And then minus 1. And this is going to be in terms of radians. So yeah, let's do this question. 2 cosine 2 theta minus 1. So it's a cosine graph. Let's see how this changes things up. All right, let's see here. So it's cosine, so it's going to look the exact same. There's nothing really that's going to change there. All right, ready? Here we go. What was the question again? It was 2 cosine 2 theta minus 1. Okay, so 2 cosine of 2 theta, and then that quantity minus 1. Man, there's a whole bunch of stuff on here. For example, we've got a 2 for the amplitude. It's not negative, so there still has not been a reflection on this yet. There is a vertical shift. It's -1. There's no phase shift because there's nothing adding or subtracting inside the parentheses of the cosine, so there's nothing there. But there is a change in the period. Since we have that 2 theta, we're going to put 2 theta over here. And what we're going to do is solve for theta, okay? And this will establish our little x-axis. So let's get theta all by itself. Let's divide everything by 2, okay? So divide by 2, divide by 2, divide by 2. Well, 0 divided by 2 is still just going to be 0. That's no change. 2 theta divided by 2 gives us just theta by itself. So that turns into theta, which is what we want. We just want theta by itself. And then 2 over 2 gives us 1 pi. So this is our period. It goes from 0 to pi, so a period length of pi. And we just start here, 0, go all the way up to pi. Halfway between 0 and pi is 0.5 pi. Halfway between 0 and 0.5 pi is 0.25 pi, or pi fourths. And then if I go up another 0.25, that gives me 0.75 pi. All right, the vertical shift is -1. So instead of writing 0 in the middle, I'm going to put -1. And the amplitude is 2, so I'm going to go up by 2 each time and down by 2 each time. And there's my graph right there. That's the cosine graph that I'm looking for. Okay, maybe a couple more. How many more do we have on this worksheet? 1, 2. Oh, just 2 problems. Okay, we'll do these 2, and that'll be it for this video. So graph each function using degrees. Okay, no problem. And it looks like they're throwing everything at us now. My goodness. Okay, so it's a cosine graph. So let's go to the cosine graph. That's this one. And let's change it up, to fit the graph that we're trying to make. All right, here we go. So it's cosine of theta minus 60 plus 2. Okay. Cosine of theta minus 60. And then plus 2 or minus 2? Which one was it? Plus 2. Okay. Plus 2. All right, so here we go. Ready? It looks like there's not any number that's multiplying on the cosine or on the theta. So that means it's not going to affect the period at all. And I think this is in terms of degrees, so I better put 0 to 360 here. There we go. The amplitude, there's nothing multiplying on the cosine, so the amplitude is going to default as a 1. The vertical shift, we do have something. It's going to be up 2. Since there's no negative amplitude, there's not going to be any reflection. But there is going to be a phase shift, and let's see how to make the phase shift in there. So the stuff that's in the parentheses, I'm just going to put over here, theta minus 60. And let's see what happens when we get theta all by itself. This is going to be pretty cool. You're going to like this. So to get theta by itself, I need to add 60 to everything. So add 60 here, add 60 here, and add 60 over here. All right, so 0 plus 60 gives me just 60. 60 minus 60, that just cancels out, so I just have a theta right there. And then 360 and 60 gives me 420. All right, so how far away is 420 from 60? Watch this, ready? 420 minus 60, it's still going to be 360 degrees. So that's the length that we have. Oops, not period, none. Period is 360 degrees. It's the length from like the beginning of our sine curve to the end. And the beginning of our sine curve is this value. That's what gives us a phase shift. You know how usually we've been starting at 0? Now this thing is going to start, because the leftmost value on the inequality is 60. It's going to start at 60. And it's going to go all the way up to that 420 degrees. Halfway between 60 and 420 degrees, well, let's use our little calculation for this. 420 plus 60 and then divide by 2. So that'd be 480 divided by 2, which would be 240. So 240 degrees between those two. And then, you can find halfway between the other ones as well. Halfway between 60 and 240, I'd add them together and divide by 2. So 60 plus 240 is 300, and 300 over 2 is 150. Notice that these are 90 away from each other, and so are these. They're 90 away from each other. So if I add 90 on a 240, that should give me my next number, which is going to be 330 degrees. Which is the same, by the way, if you did 240 plus 420 divided by 2, it should give you the same thing. Okay, anyways, so there's our x value, our x-axis, and that's going to be the only thing that's kind of like a little bit weird. Everything else is going to be about the same. But watch this. So the phase shift. So since it's a positive 60, what I'm going to say is that this is going to be a phase shift of right by 60 degrees, okay? If it was a negative 60 instead, I'd say left 60 degrees. Because what it does is it just moves the graph to the right by 60 degrees, but it's a standard cosine graph, so everything should stay about the same other than that. Vertical shift is 2, so instead of putting a 0 there, I'm going to put a 2 there. And then the amplitude is 1, so I'm going to keep going up by 1 each time and down by 1. And there's my cosine graph. That's how you would do this one. Excuse me. All right, I've got one more to do, number 19. Let's see how confusing this one gets. So graph each function using radians, and I'm going to be using sine, and they're throwing just about everything that they can at us. So 3 sine of theta minus pi thirds. Okay, so I go to my sine graph. That's this one right over here. And let's see, what did they give us again? It was 3 sine theta minus, so 3 sine of theta minus pi thirds. And the pi thirds subtraction is in the parentheses, so that's not a vertical shift, okay? And we're dealing with radians, so it's going to go from 0 to 2 pi. Let's see how things get changed up from all this. Okay, so here we go. Our sine graph stays the same. It's never going to change unless we have like a negative reflection, so a reflection over the y-axis. All right, so let's see what happens with this amplitude. Yes, we have an amplitude of 3. There is no vertical shift because there's nothing adding or subtracting at the very end over here. There is no change on the period because there's nothing multiplying on the theta, so it's just going to be a 2 pi period still. There is no reflection because the amplitude is not negative, so none there as well. And the last thing is just going to be the phase shift. So here's how we get the phase shift. Ready? We just do 0 or theta minus pi thirds. And we just get theta by itself. So how do you get rid of a minus pi thirds? You add pi thirds to everything. So add pi thirds, and add pi thirds. So 0 plus pi thirds is going to give us pi thirds. And by the way, this tells me like the phase shift already. If I get theta by itself, and on the left-hand side of the inequality, I get a pi thirds, and it's positive, I'm just going to be moving my graph to the right by pi thirds because it's a positive pi thirds. If it was negative, I'd say left pi thirds. Okay, and then the last thing I got to do is 2 pi plus pi thirds. So this is going to be some fraction stuff. Like I've got something nice that you can do with your calculator if you're allowed to use your calculator on the test. I don't know if you are or not. But what you can do is just add the numbers without the pi's on them. So you can do like 2 plus 1 over 3 because that's like 2 pi plus 1/3 of a pi, and then just like complete it and then hit math and then fraction, and you can convert it back to a fraction. So it'd be 7 pi thirds. Okay. So this ends up being 7 pi thirds right here. Of course, you can always use like, fraction algebra for this. Like if you had 2 pi plus pi thirds, what I'd want to do is find the common denominator. So I multiply the top and the bottom by 3. So that would give me like 6 pi thirds. And then 6 pi thirds plus 1 pi third is 7 pi thirds. That's the real way that you get it, but whatever. Okay, so we've got pi thirds and 7 pi thirds. So what's halfway between 1 pi third and 7 pi thirds? Well, what's like halfway between 1 and 7, right? Like, so halfway between them, let's see, that'd be 1, 2, 3, 4, 5, 6. So let's see here. Looks like it'd be 4. 4 is halfway between, so that'd be 4 pi thirds is halfway between them. And then what's halfway between 1 pi third and 4 pi thirds? Well, what's halfway between 1 and 4? So let's see, 2 and 3. So it'd be like the halfway point right over there, right? So it'd be like, I guess 2.5 pi over 3. And then you can, if you multiply the top and the bottom by 2, you get 5/6 of a pi. That's where you end up with. And then what's halfway between 4 pi thirds and a 7 pi thirds? So 4 and 7. It'd be like halfway between there. So 5.5 pi over 3. And then if you multiply the top and the bottom by 2, 5.5 is 11. And then, 3 times 2 is 6. So it's 11 pi over 6. Okay, and then we can do our little right-hand side. There's no vertical shift. I mean, the y-axis, there's no vertical shift, so 0. Amplitude is 3, so we go up by 3 and down by 3 each time. And that's our graph of 3 sine of theta minus pi thirds. Okay, I hope that was helpful. I know I just did a couple of them, like kind of quick, but it's just a nice little review for you. All right, that's all I got for this one. I'll try to make some more of these in a little bit. Thanks for watching. See you later. Bye-bye.